we deposit $1,500 each year for 10 years and we paying 2% interest. How much will you have in your account after 10 years? The income function for our deposit is, let me put this, will be C of T is equal 1,500. What else we know? We know that our interest rate R is equal to %. This is equal 0.02. We will give this money for 10 years. So T is equal 10 years. We will use formula for anode of annuity. Let me remind you. Is equal e to power r, capital letter T, integral from 0 to t, C of t times e to power negative r, small letter t, dt. So this is equal, have to copy e, r is equal 2%, so is 0.02. T is 10, so we put times 10. We have integral from 0 to 10, definite, and C of t is, in this example, equal 1,500, our deposit money, and next we have e to power negative r again is 0.02 times t, lowercase, and we have integral with respect to t. So this is equal, we will have e to power times 10, so you have to move 1 to the right side decimal point, so it will be 0.2, and we can take this constant before integral symbol, so we have times 1,500, and we have definite integral of from 0 to 10 of e to power negative 0.02 t dt. If you forgot how to solve this integral, let me remind you, we will use substitution method. Let me put that negative 0.02 t is equal our u. So now we have to find derivative of both sides with respect to t, so it will be negative 0.02 is equal du to dt. Now we multiply both sides by dt. So I will change the side, so it will be du is equal negative 0.02 dt. Because in our example we have only dt here, so I will divide now both sides by negative 0.02. So we will have that dt is equal, we have negative in denominator, so positive over negative will be negative, and we have 0.02, so I will change this to fraction, so it will be 100 over 2 and times du. So this is equal negative 50 du. So now we have to come back to our integral. We can use calculator to find how much is e to power 0.2 times 1,500. This is 1832.1. So we have, this is equal 1,832.1, And now we have definite integral from 0 to 10. I didn't change limits, so at the end I have to come back to our substitution before I plug the limits. And we have integral of e to power, I substitute negative 0.02 by t by u, so we have e to power u, and dt is equal negative 50 du. So this is equal negative 50 I can put before integral symbol, so we will have 1,832.1 times negative 50. And now integral of e to power u with respect to u is e to power u. And we have limits from 0 to 10. Now we have to come back to our substitution. So this is equal. Positive times negative give me negative times 50. So this is equal 91,605.2 approximately. And we will have e to power u is negative 0.02 t, limits from 0 to 10 we have. So this is equal, have to copy constant. And now we have to plug first upper limit, so will be in brackets e to power negative 0.02 times 10 minus, and we have to subtract the lower limit, so when I substitute t by 0, so will be 0 times this expression number give me 0. So we have e to power 0 is 1. So this is equal. We can use calculator. We will have negative 91,605.2 times, and in parentheses we have e to power negative 0.2 will be because we multiply by 10, and we have minus 1 close parentheses. This is equal 16,605.2, of course, dollars. This is my solution.